Hello again, guys. So, another problem. The ring of negligible size is subject to vertical forces of 200 pounds. And these two tensions here. Why? My question would be why do the problem states that the ring is negligible in size? Two things. First, do not get confused with this and a pulley, small pulley, because this is not a pulley, it's a ring. So why do the problem is telling you that it's negligible in size? One of them could be the weight of the ring, one of the reasons, which is negligible in this case. And the other thing is that if this is not negligible in size, maybe these three forces are not going to get concurrent at that point, and then we wouldn't be talking about particle equilibrium. But anyway, this is transparent for us. It's a particle equilibrium problem, just like that. And the free body diagram will be something like that because it says that AC is 160 pounds and we don't know AB and we don't know this angle also. So those are two unknowns, AB and the angle, and in this other side I have this angle of 40 degrees, alternate internal angles, alternate internal angles. So how do we solve this problem? We have two equations, we have two unknowns, solve for system of equations, x and y. Summation of forces in x equals 0. By the way, this thing that is like there is because it was a hint. I know you don't need hints. I hate hints. I want you to focus and try to solve how to do that. Basically, as I say, the problem is asking for what is the force in the cable and what is the length. Yeah, but I can get the length if I know the angle. So I'm not going to focus now on the length. I'm just going to focus on the angle, and with the angle, I will calculate that length. Good. Anyway, summation of forces in x equals 0. So I have this x component and this x component. That will be minus to the left, 160 cosine of the angle, plus to the right, AB cosine 40, 0. And I'm going to solve here for AB because I know I'm going to have to need it for working with the system of equations. So I'm going to solve for AB, which is going to be equal to 160 cosine of the angle, passing it to the other side, divided by cosine of 40, or AB will be 160 divided by cosine of 40 degrees. That will be 208.8 208.865 cosine of theta. So that would be, let's say, my first equation. These are these. And when I say summation of forces in y equals 0, then we have this component, 160 sine of the angle, positive, this component, AB sine of the angle, minus 200 equals 0. So what do we have here? We have 160 sine of the angle plus AB sine 40 minus 200 equals 0. That will be our equation number 2. And I'm going to put the value for AB here. So basically what we have will be 160 sine of the angle plus AB, but AB is this, 208.865 cosine of theta, that will be AB, right? Times sine 40 minus 200 equals 0. Or I will have 160 sine of the angle plus 208 times sine 40. That's 134.26. 26 cosine of the angle minus 200 equals 0. How do you solve this system of equations? Well, you can solve this system of equations by using trigonometric identities and working this problem and trying to go crazy, and maybe 5, 7, 8 hours after that you have the solution, or you can use the good old faithful trial and error method. What is trial and error? Well, basically trial and error just try for you to prove some values for the angle and get the results here, and at some moment they are going to converge. The way that I have the equation set up, once I find the correct angle here, I should get 0. Expected result 0, because this is the way it is set up. So let's try to do that. I'm going to establish this equation here, 160 sine. I'm going to start with 0. Let's say 0, 0.00. That's my first guess, not guessed, plus 134.26 cosine 0.00 minus 200. Now, do you imagine the surprise that I hit enter and I got 0 here? That would be awesome. No, but I should get 0, right? So let's see what happens when I hit enter. When I hit enter here, I don't get 0. I get negative 65.74. So that's just my first guess. Now I'm gonna go up and I'm gonna change my guess, and I can try with 45 or 40 degrees. That means that wherever I have 0.00, I'm going to copy 40 degrees, 40 degrees, and for 40 degrees I get 5.695. You see what happened here between 0 and 40? I have a 0 crossing. That means the answer is going to be somewhere in between 0 and 40, at least one of the answers, because when you have this type of situation, sine, cosine, most probably you have two different answers. So the first answer is going to be here between 0 and 40, but it's going to be really close to 40. You can even interpolate, and that's what we should do. You have 0 here as the first value, you have 40, and here you have negative 65, and here you have 5.695. This is 0, this is 40. That means that my answer is going to be somewhere here, where the 0 crossing is the value that satisfies that function over there. So then I'm going to try 33 degrees and see what happens with 33 degrees. I go up, and I just have to substitute here in my equation 33. And I go here, 33, and then I get negative 0.257, which means basically that you see there's still a 0 crossing between 33 and 40, but really close to 33 and a little bit bigger than 33. 33 would be somewhere here. We're in the negative part still, so this is not the scale, so it should be different plotted. But it's going to be bigger than 33, slightly bigger than 33, but it's going to be smaller than 40. So let's try 33.25. So if I go 33.25, and I substitute these values here. 25, 25, and I get 0.0067. To me, that is close enough to say that this is the solution. But if you check these two numbers, you see 33 is this, 33.25 is this, so it should be a value that is smaller than 33.25 slightly. So you can try 33.24 and see what happens. But I'm okay with these results. So this will be one of the angles. Now what happens if I try in the other spectrum, because I was in 40 and I just stopped over there. Let's say, what would happen if I say, okay, I'm gonna try 70, because it might be another solution. Usually there is another solution. So I'm gonna try with 70, 70. Oh, I mess up me messing up my solution. Me, puny human, shouldn't do that. Me, puny human has to start again. And I'm gonna copy this again because puny humans like me do that. Sine 70, we say, right? Plus 134.26 cosine 70 minus 200. So if I try 70, I have 40. Now if I have, let me put the 40 here, like if I going in that direction again, 5.695, and I have 70, and I get negative 3.73, that means that there's another answer. There is a second answer here in between these two values. So what if I try, I don't know, and I know the answer has to be smaller than 70, but bigger than 40, because the zero crossing happens between those, and I know that has to be really close to 70. So what if I try 67? 67, so I go up, and I change this by 67, 67, 67, and then you get negative 0.26. What does that mean? That means that the value has to be smaller than 67, but slightly smaller than 67. So 66.75. So let's go up and let's go 66.75. See what happened. 66.75. You see, the solution was really fast. I mean, finding the equations and now solving this simple equation. Okay, 0.005. That to me is also really close. So you're going to have two different angles that mathematically satisfy that equation. Now, that means that we will have also two different lengths. And how can you find those different lengths? Well, I know the value for uh, I know the value for I have my equation. So if I want to know the value for AB here, AB will be AB, let's call AB1 for the first one, it will be 208.865 cosine of this, and AB2 will be 208.865 cosine of this. For the first one, it will be 208.865 cosine of 33.25. The first value for AB will be 174.67 pounds, and the second possible value for AB will be, let me go in just change the angle. 66.75. That will be 82.45. 82.45 pounds. Pounds. Yeah, but that means also that we're gonna have different length. One length for this one and one length for this one. So how do you find the length? Well, we can find the length by using trigonometry, any type of trigonometry that you want to. Because I can come here, for example, right? And I can calculate this height. I know this length, 2 feet, and I know this angle. So I can know beforehand how much is that. If I say tangent 40 or sine 40 here, I can say sine 40 degrees is y divided by 2. That means that this height is fixed as 2 times y is going to be equal to 2 times sine 40. 2 times sine 40, 1.28, 1.286 feet. And now if I know this angle theta here, I can say also that sine theta will be that divided by L. 1.286 divided by L, or L is going to be equal to 1.286 divided by sine theta. Meaning, for AB1, we say theta was 33.25, so L1 will be 1.286 divided by sine of 33.25. 1 divided by answer divided by sine of 33.25. That will be an L of 2.34 feet. And L2, using the other angle, will be 1.286 divided by sine of 66.75, and that will be 1.286 divided by sine of 66.75. That would be 1.40 feet. So these are the possible solutions. This force with this length, or this force with this length. You see, this is a problem that it was really easy, but finding the solution became kind of complicated. Now, I know the video is a little bit long right now, and you don't like long videos, but hey, don't watch it if you don't want to. But this is important. Let's say that your professor allows you to use this calculator, and you don't have to use trial and error. Then you can plot this function. This function here, I can plot it. So I'm going to plot the function. I already did it, but this is not the function. So 160 sine of the variable plus 134.26 cosine of the variable minus 200. That's the value. That's my function. Now I say graph. And when I graph the function, if I get any result, I'm getting results, really weird results here in this part. So let me try to find the function again. Because I put 2000. Look at that thing. Oh, please. Do what I said, not what I did. Now, graph. Oh, now we go. You see, I have one intersection there and one intersection there. The zero crossings are going to be the values that I'm looking for. So how do we do that? You can use the function calc here and look for zeros. Now the software is going to ask you for a left bound, so try to go before the first intersection. It doesn't matter where, but before the first intersection, and a right bound, go after the first intersection, There you go, right there. And then any guess, it doesn't matter. And then we get the first value. You see 33.24. And we got in our trial and error 33.25. So basically, this is perfect matching with these two solutions. Now for the next solution, same thing. You go to calc, go to zeros, and then you go slightly before, slightly before, slightly after for the right bound. Any guessing, initial guessing, and you get 66.754. 66.75 is the value that we got here. So that's another way that you could find those solutions also. Uh, yeah, that's about it. I know it's long. It looks really easy, and it's easy. You see, the only problem with us was finding those roots for the equation, that equation, finding the possible values of the angle so we can finish the problem. But check this problem again and try to solve it. There are professors that really like this type of situations. Me, myself, and I, not so much. But it's okay. Thank you for watching, guys. See you later.